Hello, and welcome to another Unreal Engine 4 tutorial. In this video, we're going to be creating a security camera system that is going to be able to sweep back and forth over a predetermined path, and then it will be able to catch a target that enters its line of sight and follow that target. After that, we are going to use render targets to capture what that camera sees, and then display it onto a monitor in the game world. We're then going to create a material that uses a bunch of different material effects to make that monitor look like a classic CRT monitor. So without further ado, let's jump in here and get started. So as you can see, I've already started off with the third-person blueprint just because that'll be easy to demonstrate the camera functions such as following targets. Also, I have imported my meshes already, so I have a security camera. I also have a security monitor, and one thing to note about this, which will be important for later use, is that we have UVs specifically for the screen. I also have UVs for the rest of the monitor, but we're not really going to use those. We're just going to mask using vert colors to tell it what colors to give to the rest of the monitor. However, we will be using specifically this channel of UVs so that the render target that we're capturing of the camera's perspective will be displayed without a ton of distortion onto this monitor. So it will distort a little bit because the aspect ratios aren't perfect, but it won't be noticeable. That is probably the biggest thing here that you want to make sure that you have right, is that you have properly set up UVs for this kind of effect. We're not going to go too much into the camera itself because really that's just an asset that's there to make the effect a little bit more believable. You don't really need it. You could have the camera in a different room than the monitor and you may never see it. So it's not necessary for the effect. It's just there to give us something that makes this a little bit more tangible for the tutorial. I've also already made materials. So this is for the camera. I'm just doing some vertex color masking for colors. And I'm doing the same thing in the monitor, although the monitor effect will get a lot more robust by the end of this tutorial. So there will be a lot more in this one, and we're going to be expanding upon this material over the course of the tutorial. But for now, these are just masking with the same vertex colors that I showed you a second ago. So if I turn off these UVs, you can see we're essentially just masking the different parts of the screen to tell the material where to display certain things. So if I drag this monitor in here, it's huge, comically large, which is better for being able to see the effect that we're going to have later. But you can see that we've just masked off certain things for different colors and different properties like roughness and metallic. So that is basically what we have to start off with. But now we're going to get into actually creating the blueprint for the security camera and how that's going to work. So the first thing we need to do here is to create a blueprint class. We're going to go actor, and we're going to name this BP security camera. And we're going to open it, and we're going to add a static mesh component to it, which will be the camera itself. And we'll change that static mesh to camera. Well, security cam is what I named it. So you can see it's pretty big. Also, we're going to do some scaling and also just positioning of it so that it looks a little bit better. So we're going to move it down a little bit on the Z by 12. We're going to rotate it down on the Y by -20, so it's kind of got that position of like a security camera on the ceiling that's just kind of looking down. And then we're going to scale this by 0.5 on all axes. And of course, that's going to depend entirely on what you've done with your model, but I made my model very large, and it's still going to be kind of a large camera, but this is much more realistic. So then what we need to do is we need to add a scene component, and this is just sort of a temporary thing that I'm going to do. Really, this is not necessary for the final effect, but I'm just using this because I don't want to add the scene capture just yet. But we're going to add a scene capture later that could also be used to fill what this scene component is doing. And essentially, what the scene component is doing is it's marking a location in the actor that I can then pull off of for various things like line tracing. So we're going to place the scene component as a child of the camera so that it follows the camera around when the camera moves. And then we are going to put it at 232 and negative 40-ish. Actually, maybe a little bit lower than that. You basically just want it, you want it to be sort of in the center-ish, and it doesn't have to be perfect, but in the center-ish of the lens. And then once we have that, we're going to add one more thing, and we just want this to be parented to the root, but we're going to add a cylinder. And this is purely just for aesthetics, but this will be scaled a little bit. Whoa. This will be scaled a little bit, 0.15, 0.15, and 0.5. And so essentially you can see what that's doing is we're just giving a post for the camera to hang off of, so that when it rotates around, it doesn't look like it's just floating. It looks like it's attached to something. So we've got these three components now, so that's all good to go. So now we can start to set up our sweeping motion where the camera is sweeping back and forth over an area, just surveying a room, essentially. So the first thing we're going to do is go into the event graph and add a timeline. So we'll name this timeline camera sweep, and then we will open it. We'll make it 6 seconds long, and it will loop, and we're going to add a float track to it. And then we're going to start adding some keys here. And so essentially we want to have something that loops smoothly and starts off without pointing to one side or the other. Just starts off in the center and then sweeps to both sides. So we want to start off at a time before 0 so that we can get it at 0 when we want it to be, and also make it look perfect. So it's going to be sort of sinusoidal in behavior, but sort of sinusoidal, but it'll be offset. So what we're doing is we're going to go negative 1.5 and negative 1 for the value, and then we're going to put another point at 1.5 and 1. Whoop. Auto saving on me. 1.5 and 1. And then we're going to have a little bit of a break in here, so about 3 seconds, and we're going to go to 4.5 seconds, and we're going to go back to negative 1, and then we're going to go to 7.5 seconds, so again past the limits of our timeline, what our timeline is reading, and go to a value of 1. And then we're going to go select them all, right click, and go to auto interpolation so that it's a nice smooth curve. And so essentially you can see what it's doing is it's starting off at 0, it's ending at 0, it sweeps left and then right. So that's perfect. That's exactly what we want. We want to plug event begin play into play from start. And then we want to get the camera, and we want to set relative rotation and plug that in update. And then we want to right click on the input of rotation and split the struct, and then we're going to make the y negative 20, the x is going to be 0, and then we are going to lerp, the z, because we want it to be rotating only on the z, essentially. So we'll say actually it did a lerp rotator. Whoops. So we want a lerp float. I don't know why I clicked rotator. Just a little brain fart there. Okay, so we want to go from 0 to 30, and then we want to plug that into the z. So essentially, if this is working correctly, which I think it should be, if we drag a camera out into the world here, you'll be able to see that it's just sweeping back and forth like so. And there's a little bit of downtime in between the sweep, which is perfect. So we have some very basic behavior there. The next thing that we're going to want to do is give it the ability to see targets, to essentially, like if something breaks its line of sight, then it should be able to lock onto that thing and follow that thing. So the first thing that we're going to do is we're going to set a timer by event. If you're unfamiliar with this node, it's essentially a node that can delay and loop and then every time it reaches the end of that time, it fires off to an event. So I can say, which I will do here, 0.1. So every 0.1 seconds, if I have this checked as looping, it's going to fire off to call an event, which we're going to create here, add custom event, and we're going to call this look for target. So now every 0.1 seconds, we're going to start calling this event. And this event is going to be a line trace, essentially. So we're going to line trace, and we're going to do line trace by channel. Obviously, this is not going to be perfect for a camera because a camera has a pretty wide field of view, whereas a line is going to be dead down the center where the camera's looking. So it's not going to be 100%. If you wanted to, you could do a sphere trace or like a overlap trigger trace, some things like that. However, I'm just going to do this line trace because it's very simple. And I'm more focused on the material side of the effects and all that. So if you really want this camera to be great or perfect, you can just you can do a different kind of trace. It'll be a little bit more complex, but it's the same general idea is what we're doing here. So we've got our line trace. We want this to draw a debug so we can see what it's seeing. And then we are going to tell it where to trace. So the reason why we have the scene component in here is specifically for this. We're going to drag the scene component out here. We're going to get the world location. So that is going to be where we want the trace to start. And then we're going to go back to the scene component and get the forward vector. And essentially what this is going to do is get a vector that is pointing in the scene component's X positive direction. And since this is going to move with the camera, it's always going to be the X positive direction of where the camera's looking. So we've got that now, and what we want to do is we want to multiply this by a large number. So essentially we're saying we have a direction and we want to go pretty far in that direction. I'm going to give it 5,000 to start with. I think that'll be good for what we're doing here. It's really going to depend on the size of environments that your cameras are going to be in, but this should be a good starting point. And then what we're going to do is we're going to vector plus vector, so add these two together. So you're taking this direction, you're giving it a distance to go, and you're adding that back to the location to say, start from the camera, go out in this direction for this far, and that will be the endpoint. So now we have that. We're gonna just take a look and see what it's doing. So you can see it's drawing lines from the lens out a distance that we set, and then it should be catching me, but it's not, and there's a reason for this that is a little strange. But if you go into the third-person blueprint, third-person character blueprint, you open that, and if you look at the capsule component and you look at the collision presets, it's not triggering a visibility trace response, and the same for the mesh. So if I can find, so you can see here, it's not triggering a visibility trace response, which is why the camera is not seeing it right now, because we're tracing on visibility. I am going to use the capsule component. I'll show you really quick why I'm doing that. So if I go here and change the character mesh to custom, collision presets to custom, and then change the visibility to block, then you will see an issue really quick where, I don't think that's actually, there it is. So you can see it's catching at some points. If I can just get my cursor back real quick. So you can see it's catching at some points, but then it's able to shoot like through his arms. You don't really want that because that wouldn't make sense for a camera. The camera is going to see them regardless of if it's looking straight at their arms or not. So we're going to go back and we're going to change that back to what it was. And we're going to do the capsule component instead. So go pawn to custom collision preset and change the trace response to block. And then we go back and look once again, and you'll be able to see that it just, some of these are drawing for a little bit too long, but you'll be able to see that it just hits him no matter if it goes through his arms or not, which is perfect. That's what we want. So we have a response here. That's great. We're getting somewhere with this, but it's not quite what we need. So you can see that, like, if I look at this again, it's also just hitting the ground, and it's not making any distinction between what it's hitting. It's just, it's hitting a thing and then it's saying I hit a thing. So we actually need it to be able to make a distinction between whether or not it's hitting the ground or a character or something like that. So what we're going to do is we're going to create what's called an interface. So we're going to go right click, blueprints, blueprint interface, and we're going to call this blueprint interface cam target. And what an interface is essentially a class that actors can inherit from, or an actor that actors can inherit from, and not necessarily have that as their parent. So you could have, for instance, a child of this blueprint that still inherits from this, and so it can inherit from these two different things, which is really useful because you could have, say, for instance, character pawns and then items, and you want them both to be interacted with by certain things, but you don't want them to have the same root parent. So then you can use this interface as a way to give functionality to both of them without having them both be parented to the same thing. So if we open this up, you can see you can add functions, and those functions can then be overridden in anything that implements this interface. So if we compile this and save it, we can go in and go to the third person, go to class settings up here, or third person character blueprint, go to class settings up here, and then go to interfaces on the right and add, and we're going to go to cam target. And that will be what we're adding as the interface here. I guess you could probably add multiple interfaces. So there's a lot you could do with this. We're just going to add the one. So if we go to the security camera and then we get this out hit result, break that. And then we get the actor and we say does implement interface, and then look for the cam target. Then we can get a branch here. And if it does implement the cam target, then we're going to just print hello, and that'll show us how this is working. So now you can see it's hitting the ground. It's not doing anything. It's not saying anything. Now, whenever it hits the player or the pawn that's implementing the interface, it says hello. So this is a really great way to be able to interface from different blueprints without them having to know what the other blueprint is. So you can do functionality that otherwise you would have to get a reference to the pawn, and then you have to cast to the specific type of pawn, as opposed to just being like, this is an actor. Does this actor have this interface? So that's super useful for things like if you had like an item system in a game and you had a bunch of different type of items, and some of them were potions and some of them were weapons, but you wanted them all to have different parentages, but then you wanted to be able to reference them all in a certain system. Like I can pick them up, but they don't do the same thing. And I don't have to know what they are when I'm trying to pick them up. This is perfect for that. And then also we're going to extend this a little bit such that we have a function that we are referencing in here. But we're not going to do that just yet. We're gonna start off with this very simple interface here. So we're going to delete this because we don't need it to say hello every time. And we'll probably get rid of the debug trace on the line trace because we don't need to see that now. I might actually drag this down a little bit more too. So it'll be easier to break its line of sight in the future. So what we're going to do here is, now that we have a hit response and it's able to differentiate the player from the ground, what we're going to do is we're going to have it follow the player when it hits them. So once the player breaks the line of sight of the camera will stop sweeping and it'll follow the player. So the way that we are going to do this is we're going to create another timeline. And I'm going to use timelines a lot here. I like timelines. I find that they're a super easy way to do these things, to play and stop things on cue. They can be a little expensive. It's not as expensive as doing something on tick, but there are costs associated with that. And you can do things by setting event timers like I also did in this. Just keep in mind there are a bunch of different ways to do this, but I find that timelines are super useful for these kind of things. So we're going to call this, I guess, follow. Well, it just screwed up there. Save follow target. So we're going to call this follow target. So when we break the camera's line of sight, we're going to get followed by this. We're just going to loop this indefinitely. We don't actually care about the float value in here. We just want this to constantly tell something to update, and then to be able to stop it and come back to it later and restart it. So, so we have this set up. The other thing we want to do is we want to promote the target to a variable here. So we're going to call this target. And as soon as we hit this, we want to set it as the target and then plug that in there. So now that we have done that, we are going to get the target over here. Get the target, and we're going to get actor location. And then we're going to get the camera. I'm going to get camera, get location. I don't know why I was typing in get camera location. And then now we want to do something called find look at rotation. Basically, you just input 2 different locations, and it'll find the forward facing vector from the start location to the end location. And the way we're going to use that is we're going to set the world rotation of the camera, plug that in on update, and then we're going to set that as the new rotation of the camera. So now if we go back, you can see that once we break line of sight, the camera will follow us. So perfect, working exactly like we want to. Now we're going to go back in here and do a little bit of cleanup, because there are a couple things we want to do here. So we want to be able to have this thing lose line of sight with the player, and we also want to make sure that it's not playing the sweep motion when it's tracking the player and vice versa. So first thing we're going to do here is tell this to stop, and then start the follow target whenever it catches a target. Second thing we're going to do is we're going to duplicate this, and then when we lose the target, we're going to stop this timeline, and we're going to start this timeline. So those things should work pretty well in tandem to make sure that we're only doing the one motion that we should be doing. So now you can see when it loses track, it just snaps back. However, we're going to fix that in a minute. But yeah, you can see it's kind of glitching out right now, but we're going to fix that in a minute. The other thing you'll notice is that it's kind of looking at the pawn's feet. So we're going to need to fix that. So we're going to fix that first. You can go into the interface, and we're going to rename this function to be a get look target. So I got get look target. And the first thing you'll notice is that when you go into any of these, any blueprint, basically, you can call any of these interface functions. So we can call it in a third-person character. You can just call it here, and then you can plug in the target, essentially. So you could go into here, and you could do the same thing, get look target. To plug in the target and say, we want this specific class to call this interface function. However, if you go in here to the third person, you can also, I'm having trouble here, get look target, okay. So you can also do this class thing, which is, well, actually that's not quite working. Get look target, event look target. There we go. So you can get the event look target, and you can do it as an event where you override it. However, we want to do it as a function because we want to be able to return an output. So the way to do that is to go into the interface and go to outputs and click this little plus sign, and we're going to call this look target, and then we're going to change this to a vector. So now we have that, and now you'll notice immediately if you go back here, interfaces has popped up, and we have one function that we can override. So we open this up. We've got this here. What we're going to want to do here is we're going to want to go to the viewport, and we're going to add a scene component to our capsule. So it'll follow the capsule around, and we're just going to put that right above the head of the pawn. And then we will call that camera look target. And then we're going to grab that and get the world location. And then we're going to return that. So now, if we go into the security camera, instead of getting the actor location, we're going to delete that, and we're going to get look target. And this is going to call the function, and then we're going to return that and plug that into our find lookout rotation. So if we go look at it now, you can see it's looking at the pawn's face, and that is where it's going to keep trying to look every time it acquires the pawn. So that works. And this is super useful because just as with asking if an actor implements an interface class, where this doesn't really need to know anything about that actor other than whether or not it implements the class. This also doesn't need to know anything about how this interface function works. So it's basically just calling this, and if this target has that interface function, then it'll do whatever the interface function is overridden to do in that actor. So you can essentially have two different actors that have two different functionalities. So we could, for instance, have a cube that is another look target that we could get, and if the cube moves in front of the camera, and the camera starts looking at it, we can have it return just the origin of the cube, for instance. It doesn't have to have the same kind of setup that the third-person blueprint does. So that's pretty useful. So we have that now. So we're looking at that, and we can close the third-person character and the interface because we're not really going to change anything else in there. We've got all the functionality that we need. We're instead going to focus on fixing up this this camera functionality so that it looks a little bit nicer. It's not going to be perfect, but it's not going to be as snappy, and it's not going to have that weird little glitch that we were experiencing a minute ago. The first thing that we're going to want to do here is we're probably going to want to refine how we're doing the targeting in this, or moving from the targeting to the back to the sweep motion. So the way that we're going to do that is we are going to add another timeline in here that is going to lerp between the location that it last saw the target at to the original location of the rotation, the original rotation of the camera. So we're going to call this return to sweep. And we actually want to only do this once, and then reset it whenever the camera finds a target again, because otherwise, whenever it loses a target, it's going to try and do this and this. So we're going to say that when it loses a target, instead of going straight up into camera sweep, it's going to go here into the do once. And then on top of that, whenever we get a target, we're going to reset this do once. So that will work perfectly for our purposes. We're going to open this up, and we're not going to have this looping. It's just going to play once. It's going to have a length of 2 seconds, and we're going to add in a couple of points in here. So we're going to go 0, 0 and 0, and then at time 2 it'll be 1. So essentially over its life from time 0 to time 2 is going from 0 to 1. So it'll lerp between the two rotations that we're giving it. So if we go back, you want to do a couple things here. You want to drag off of the finished and tell it to play the camera sweep once it's finished. So it's basically just it's just going to lerp, and then it will immediately resume sweeping once it's done lerping. So the other thing we want to do here after this, let's keep this clean. Doing this with multiple timelines can be a little messy, so you want to make sure that you're keeping this organized. So what we want to do first here is we want to get the relative rotation of the camera, and we are going to promote that to a variable, and we're just going to call this last scene location because it's the last location it saw, or the last rotation. Yeah, we should rename that to rotation. The last rotation it saw whatever its target was at. So we've got that there. And now we want to lerp rotator this time, actually. And we want to plug in the last scene rotation into A. And then B is just going to be 0, -20, and 0, which is sort of our original rotation there. And then we are going to set the relative rotation of the camera. We're going to plug that in there. We're going to plug this in here. Okay, so that should be good. We just want to make sure that we've got everything in here set up well. The other thing that we want to do is make sure that if we acquire a target, we stop this. So even if we're currently lerping between the two rotations, we can still stop and acquire a new target. And I think that should do it. Let's give it a shot and see what it does. So we immediately acquire the target. You can see once we lose the target, it lerps back to its original position and then starts sweeping again. So perfect. The only issue we really have here is that when we acquire the target, it kind of pops a little bit because we've set the target above the head of the pawn, which is not where the camera was looking initially. And I'm not really going to fix that here. It complicates it a little bit, but it's definitely easy to do with the same methods that we're doing here. So you can definitely do that. I'm just not going to do that here. I think this is a good enough behavior for us to move forward with. So we basically have all of our targeting sorted. So the camera is doing what we want it to do. Now we need to move on to capturing the scene and then displaying that on a monitor. So the first step we're going to take in that is we are going to add a scene capture component 2D to the camera. And we're going to call this camera capture. And the reason why I was saying you could use this instead of the scene component is because we're going to put this in almost the exact same spot as the scene component. It's really, it's more useful to use as that because it's also being, the scene capture. So we could just get rid of the scene capture and the scene empty component and use the scene capture component for the line trace. But we're not going to do that. That's just, if you want to optimize this just ever so slightly, you can do that. But here we're going to place it in roughly the same spot and then just use it for its stated purpose, which is capturing the scene that it sees. So here we go. So it's roughly in the same spot. So now that we have that, we need to do a couple things here. So we need to, just before this set event timer by function, we need to, or set timer by event, wow, I garbled that. We need to grab the camera capture. And then we are going to set the texture for it. So it doesn't start off with a texture assigned to it. You need to set a texture to it so that it is able to write to something, because otherwise you just have a capture component that's not writing to anything. And what we're going to do is we're going to create a scene or texture render target. I don't know why I'm having so much trouble here. Create canvas render target 2D. So essentially what this is doing is creating a texture via the blueprint. And we could just go into the content browser and go to materials and textures and create a render target or a canvas render target. But we just want to do this in the game so that it's creating it when it needs it and it's not taking up like memory when it's not needed. So you want to select the class type, and that's going to be canvas render target 2D. And then we want to change the size here. You can do a lot of different sizes, but we're going to do 512 by 512. That fits our purposes. So we have this now that we have created. And then we can just plug this to into the texture target here. And essentially, when the camera starts to render, it's going to render to this target that we've just created, which then we can send to something else, which will be our monitor. So that's the next step that we're going to do here. So we're just going to compile and save that, and we're going to create a new blueprint that is going to be BP_monitor, and we're going to open that up. Or it's going to open off on a different screen. And then we're going to add a static mesh. And we're going to call that monitor. Or we're going to set that to be the monitor. We're going to compile, save. So we've got that now. We need to set up a little bit of functionality in here so that it's ready to receive what we're sending it. So we're going to create a custom event, and we're going to call this assign screen texture. Wow, I'm having trouble typing. I can't really see my keyboard, so I'm just fumbling blindly. All right, so we've got this, and what we're going to do when this is called is we're going to create dynamic material instance on the static mesh. We should call this monitor so that it's a little bit clearer. So we're creating a dynamic material instance on this mesh, and essentially what this is doing is creating an instance of a material, which will be our monitor material, that we can then change parameters on that will only apply to this specific instance. So now we're going to promote this to a variable, right click, promote to variable, and this will be MID screen texture, I guess, or monitor screen. We'll call it monitor screen. MID monitor screen material instance dynamic. And then we're going to drag off this and do set parameter, texture parameter, and then we're going to call this we're going to call the screen texture. We don't actually have this defined in the material yet, but we're going to do that in a second. And then the other thing we want to do is add an input to this this event, and this input is going to be called screen texture. Just change this here to texture or render target. So you want a texture render target 2D, and then we can plug that in. And so essentially, whenever somebody calls this event and provides it with a texture, we're going to create a dynamic material instance that has that as the texture. So we're only going to call this once, and then it will be updated through the camera. So we don't need to keep calling this. That's why we're creating the material instance in here, because this is only ever going to happen once, unless we want to switch what camera that we're using. So we are going to compile that, save it, and then we're going to come in here real quick, and we're just going to add a click and hold T and get a texture sample, and then we're going to convert this to a parameter, and we're going to call this, I always do that, it doesn't like to highlight, and it automatically makes a comment there. We're going to call this screen texture, which is what we had before. And we're going to plug that into emissive just so that we'll be able to see what we're doing. This is going to throw out an error because it is not, it doesn't have a texture assigned to it, so it needs a default texture so that if it is not assigned a texture through the parameter, it's still able to display something. So we're just going to set that to this little green guy right here. Save it. So now you can see that we have a problem automatically with this material, and that is, even though you can only see the screen on these UVs, because I've dragged the other vertices off of the UVs, it's still tiling things. So we actually need to mask this off using our vertex colors. So what we're going to do, we're going to lerp. Oh, that was the wrong lerp. Let's just hold L and click. Much easier, making this harder on myself. We're going to drag the red channel in because the red channel is the one I had for the screen. And essentially, we're just going to lerp between 0 and the texture that we're providing. and plug that into emissive. And so now that we take a look at this, as soon as it saves, you can see it's only applying the texture there, so we've got that working. The next thing we're going to do is go back into the security camera, and we need to have a way for the monitor, or for the camera to be able to communicate with the monitor. So we're going to call this a variable coupled monitor, and we're going to make this of type VP monitor. And then we're going to make this instance editable so that then when we drag these things into the world, we can actually tell them to communicate with each other by, oh, that is backwards. We can tell them to communicate with each other by that variable. So we're going to go to the security camera, and then we're going to go here and click this little water dropper under coupled monitor, and we're going to select that monitor there. So now these two monitors, or now this camera knows this monitor, so it can then talk to this monitor. So after we've done all this, we are going to grab this, get the coupled monitor, and we are going to call assign screen texture. We're going to plug in the texture target from the scene capture into the screen texture. And we're going to compile and cross our fingers and hope this works right. Yep, so there we go. So now the camera is capturing the scene and feeding that information into this monitor here. So you can see it grabs the target and it follows us around, and everything's working as it should. So that's great. That is the very basics of getting this kind of camera system set up. Now we're going to go into a little bit more detail work to make this screen capture look a little bit more like it belongs on an old CRT. And then we'll do a couple other things that are kind of interesting, like controlling the frame rate and stuff like that. But all this is a little bit more detail work. So now you have a functioning camera setup that you can use. And now we're going to dive into making it look a little bit cooler. So most of this work is going to be done in the monitor material here. And the very first thing that we're going to do is we're going to add a pixel-esque texture to it to make it look like it's a CRT TV. So I'm opening up Substance Designer here to show you what I've done to make a texture that kind of gives off this effect. So you can see I made a gradient radial, and then I made that a little bit bigger so there's less black space around it, and then I'm tiling that to create some offset here. So I'm tiling it 4 times, 4 lines, and they're offset each by about 0.5. So essentially what that's doing is creating a grid that looks a little bit more realistic than just, you know, a bunch of perfectly lined up pixels. It might not be perfectly accurate, but I think it'll work for our purposes. One thing you want to make sure is that you have an even number of rows, because if you have an odd number of rows, then you're repeating the top and the bottom row twice, which does not look good. It looks really bad. So just make sure you don't do that. Otherwise, it's a very simple texture, and I'm just outputting it as 64 by 64 because it's going to be displayed super small. You know, we're not going to see the fine detail in that. So I'm gonna import this now. Just drag and drop it, so you can see it's not taking up a lot of space. It doesn't look super great, but it doesn't need to because we're not going to see it that close up. It's going to be a bunch of these. So now to make our pixelation filter for this monitor, we're going to drag this onto the monitor material. We're going to get a texture coordinate, and we're going to set that to be 100 by 100. And we could just plug this straight in. However, we can make this a little bit more extendable by giving this a scalar that we can then change in a material instance, which is useful for just sort of figuring out how things look in the actual game. So we're going to give this a scalar parameter here, and we're going to convert that to a parameter, and we're going to call that pixel size scale. And we're going to plug that in. We're just going to give that a default value of 1.5. So now you can't really see it here yet because we're not doing anything with it, but we've got a very small grid of pixels, and then we are going to multiply. I just hit M and click. I should use these shortcuts a little bit more often. And we're just going to pull off of the red channel. We don't need all the different channels because it is a grayscale texture, so it's all basically the same. So we're going to multiply and apply that, and then we'll take a look at it. And you'll already be able to see in here the grid of pixels, but we're going to look at it in the editor. So you can see grid of pixels in here. Automatically there's an issue with it, and that is that it is much darker because we've just added a bunch of black to the image. So what we want to do is after we multiply the pixels, we want to multiply it again, and we're going to get another scalar, plug that in, and convert that to a parameter, and we're going to call that screen brightness. And we're going to give that a value of 4. So now once this compiles, you'll be able to see it's much brighter and we have our pixels. So that's looking good. And we can just real quick create a material instance of this and drag this out over here onto this this monitor, and then we can open that and we can play with the values in real time. So you can see that you can tinker with that a lot more. You can scale the pixels up if you want a really pixelated look, or you can scale them way down if you don't want to see it that much. You can tinker with the brightness. So that gives us a little bit of control, and it's pretty nice. The reason why I created the instance and then dragged it onto here was because if you use a material instance and then you create a dynamic material instance in a blueprint, it seems, at least in my experience, that Unreal then reverts all of the parameter values back to their initial values within the parent material. So you can't really mix and match the two of those. But you could, for instance, just create the dynamic material instance in the blueprint and then change the pixel size and the brightness through that. So just a thing to note there, it's a little gotcha that you can run into. But now you can see we've got that pixel filter that is now overlaid over our image of what the camera's seeing. And you can see it actually provides a neat little like movement ghosting effect when you get really close to the monitor. So that's actually kind of a neat unintended side effect of using these pixels. So now we have that. We're gonna rope that off and call that pixelation. And we're gonna move that out of the way because we're gonna be doing a lot of stuff here. The next thing we want to do is chromatic aberration. And if you're unfamiliar with chromatic aberration, essentially what that is the different color aspects of a picture are offset. So for instance, the red and the green and the blue aren't perfectly aligned, so you get a little bit of a color ghosting effect. And it's super simple to make this work. So what we're going to do here is we're going to get a texture coordinate. We're going to leave that one by one. But what we're going to do is we're going to add to that. And we're going to add a scalar to that. And this will be a parameter as well. And we'll just call this chromatic aberration intensity. And then we're going to make this a super small value because you don't want to offset it by a huge amount or it will not look good. Maybe you do want to offset it by a huge amount, but for the CRT effect that we're going for, it's not going to look super great. So we're going to plug that into the UVs here. And then we're going to copy this, make a duplicate of it by clicking on it and Control W clicking. And then we're going to plug that straight into the UV. So one of these is going to be offset and one of these is not going to be offset. And then we are going to not add, we are going to append vector. We're going to duplicate that. So what we want to do here is we want to plug in the different components of this to the append to reconstruct it after we're offsetting it. So we're going to offset just the green, and then we're going to plug R, G, and B back in to be appended back into a single vector, and you'll notice that I'm doing it in a very specific order. I'm doing it in R, then G, then B, to make sure that it's accepting the color information back in the order that I want it, because otherwise you may get some issues where you've appended the wrong value back to the wrong color channel, and so you'll have a different color channel offset. So then we're going to take this append, plug it back into the lerp, and apply that. Now, if we go back and it compiles, you can see that there is a little bit of color ghosting on the image as it moves. And then we can just go look over to see it a little bit better where it's just, not moving. So you can actually see what's happening. You can see that on the right side here, we have a little bit of red showing off. And on the left side here, we have a little bit of green showing off. Whereas this should be white because this is his eye. It shouldn't have that color ghosting on it. So if we turn this on in the instance, we can then change this so you can see a little bit better how that's working. Is we're able to offset this pretty greatly. So you probably don't want to do it too much because then you get effects like that. You could probably stop this from tiling, but even so, like the more you offset it, the crazier the image gets. So we don't quite want it to be intense, but you can crank it up a little bit if you want it to be a little bit more obvious than what it is. I think the subtle effect here is going to work the best for us though. So then we're going to rope this off, and we're going to call this screen texture, or scene texture, I guess. Scene texture and chromatic aberration. And so now we have that effect. We've got a couple more effects we want to make here though. So the next one we're going to make is sort of a noise. If you've ever watched things on a CRT over like broadcast television or from a VHS, you'll notice this noise that people refer to as snow, which is just this sort of background noise that just seems to affect the entire image. Kind of gives it a grainy physicality, and it'll really make this look a little bit more like a crappy old CRT monitor with a crappy old security camera feeding into it. So the first thing we want to do here is get, that's not what we want to do. We want to get a texture sample. If I can make it give me a texture sample. And we want to get a texture that is already in the engine. So this is going to be noise high frequency. So good 64 by 64 tiling noise high frequency. We can take a look at what that looks like. It's just a very, very grainy, just background noise kind of texture. And what we're going to do is we're going to get a texture coordinate again. And we're going to tile this 4x4. And we are going to pan this so that there's movement to it. So it's not just a static background texture. So we're going to hold down P and click to get a panner, and we're going to plug the coordinate into that. And then we're going to get a time node, and we're going to plug that into time. And then we're going to get two different nodes here. We're going to get a cosine and a sine. We're going to add these two together. We're going to plug it into the speed. So basically our speed of panning on the X and the Y are going to be controlled by sine and cosine, just to give it a little bit of variability and interestingness. So then we're going to plug the panner into the texture sample, and then you'll be able to see it working in just a second. So you can see now it's just this really like really good motion of background noise, so it's not super static looking, and it does repeat a little bit here, but once you have that as the background to an image, that'll be a lot less obvious. Also, the other thing we're going to do is it's got a lot of contrast, and it will be super obvious with that contrast. So what we want to do is we want to add 0.5 to that, which will bring up all the colors a little bit, or bring up all the values so that there aren't so many dark values, which would be super obvious. So you can see they're bright now. It's a little bit too bright though, because that's going to make our image very bright. So we're going to clamp that. So now you can see we have less contrast in there, but we still have that noise going on. And now what we're going to do is multiply this to the texture that we're getting from the camera, but we want to do this after the chromatic aberration, but before the pixels. And the reason why that is because the pixels are not going to be affected by this noise. This noise is an image quality thing. It's not changing where the pixels are, right? So we're just going to plug that. So the lerp is going to go into this multiply, and then this multiply is going to go into this other multiply. And then now you can't really see it super well in here, but if we go look at it in the editor, we should be able to see that. So you can see there's just kind of a soft noise going on in the background that gives it this grainy kind of lo-fi effect. And then if we look, you can see it on the image itself being captured here. So, you know, it's maybe a little intense, but I like it. It's got that really lo-fi effect, and I appreciate the way that looks. But you can definitely, you could, for instance, go into here and parameterize what you're adding to it to remove some of that contrast so you get less of those darker areas if that's what you want. So that's just something that you could do to customize that effect a little bit to your liking. We're going to comment this and call this snow noise. And then we've got two more effects we're going to add here. So the next effect, if you've ever seen a CRT monitor or television with a specific refresh rate being recorded by a camera that has a different refresh rate, then you will have seen in this effect. Essentially what's happening is, since they're not synced up, you can actually see the line go through the screen as it refreshes. So you get the scan line as it refreshes where these pixels are lighting up, and then it kind of fades off a little bit as the scan line moves down. So we're going to do this all procedurally here with no textures. We're going to get a texture coordinate. And then we are going to break that out into its two components. And then we are going to add to the G component, which is essentially the Y, the up, down. We're going to add 1 to that. And then we're going to append these back together. And the reason why we're doing this is because if we just left this without adding 1 to it and then started trying to pan this image down, we would just be starting at the bottom of the image due to the way the UVs are set up and then panning down, so out of view. What we want to do is start at the top of the image and then pan down across it. So this is adding 1 to do that. And then we are going to get a panner. And we are going to plug in into the coordinates what we just did here. And then we're going to leave it 0 on the X, but have it pan at -1. So basically it's just panning down now. Then we need to get another time node. And we're going to multiply this by a number. And we can actually, I haven't done this, but we could actually just parameterize this and just call this Scanline speed. And we'll give that 0.25. Plug that in. And so essentially what this is doing is it's slowing down the time value that we're getting. And then we're going to take this and get a frac. What this node does is essentially it's only counting the decimal places. So as we count onward in time, we'll get up to, you know, values equal to whatever, however long you've been playing. However, this is only going to output the fractional component of that, I guess I should say, which is just going to be the decimal between 0 and 1. It will just keep counting up from 0 to 1 every time it ticks over to the next integer. So that'll be perfect for us because we just want it to start at the top of the screen and pan down to the bottom of the screen, which will be a value of 1, and then restart at the top of the screen once it hits the bottom of the screen. So if we plug this into something that we can get a look at, we can see what that's doing. So we're going to get a linear gradient, and then we're just going to get the V portion of that, And we're going to plug this into a power node, but before we actually change the exponent on this, we're just going to look at what it's doing. So you can see it's starting at the top, it's panning down, and then it's resetting to the top. But what we want to do here is we want to set this exponent to 50 so we get rid of a lot of that contrast and we just have a semi-sharp line with a little bit of fall off in the gradient. And then we're going to duplicate this and we're going to plug this in again. And we're going to put this at 100 so that we get an almost entirely sharp interface there. And now what we're going to do is we're going to get a 1 minus node, which is going to basically flip this. So we take a look at that. You can see that's upside down now. And then we're going to multiply these two. So once we multiply these two together, the blacks are going to, the black areas of this are going to knock out the white areas of this and vice versa, right? So now if we look at it, you can see that we only have a line where we had that gradient, which is exactly what we want. And now that we have that, we're going to multiply this again because it's going to be a little bit bright the way it currently is. So 0.01, and actually let's parameterize that as well. We're going to plug that in. 0.01, convert this to a parameter. We're going to call this, God dang it, Scanline brightness. So now we can change that in a instance of this material. So you can see it's a little bit darker now, which is great because we want this to be fairly subtle. We don't want it to be crazy obvious. And we're just going to clamp this just in case. The values are probably between 0 and 1, but it's always a decent idea to clamp these things just in case you don't wind up getting a value out of these things that you don't want. If we got like a negative value and started multiplying things by a negative value, we might have some issues with weird effects happening there. So now we want this effect to come in, but we want this to happen after all of the image effects, but before the pixels, because we're refreshing the pixels themselves. So they're not, the pixels aren't moving, but we're brightening the pixels up. So we're just going to multiply that. And I should just move all this stuff back so that we have a little bit more space. And this is not as much of a nightmare. All right, perfect. So now you can see we have this line that is moving down the image, which is exactly what we want. We're going to apply that and take a look at it in the editor so you can see how it looks. Whoop, I have done something terribly wrong. What am I doing? Oh, I think I did not want to multiply that. I want to add it. You don't want to multiply it because if you multiply it, you're knocking out all of the color values where you don't have that white. So we actually want to plug that in there. We'll get rid of this. Yeah, so you just want to add to the values to make them brighter. You do not want to multiply because then you'll make a lot of things darker. Oh, did I mess that? I messed that up. Holy guacamole, Batman, what am I doing? Okay, so I made a little bit of a mistake here. You want this lerp to be the last thing before the screen brightness multiplier. Otherwise, you are going to be adding a bunch of things after you mask out the screen. So now I have this all set up. I think this should be right. So if we go take a look at it. Come on. Okay, there you go. So now masking correctly, and we've got the scan line added in here, and everything's happening in the proper order. So just make sure you have everything in the proper order here because the order matters quite a bit. And once you get a bunch of things plugged in here, it can be a little bit confusing to make sure you have everything plugged in correctly. But this is the way it should be done in, and just make sure when you're adding a bunch of effects in like this as well to kind of consider what the effects are doing and which one should go first. So like I've been hammering home this entire time, things like the pixels will be the last thing because that's the fundamental makeup of the image, whereas image quality things are going to happen further up the pipeline. So just keep all that in mind and make sure that you're organizing these things well. Now we're going to do the last effect that we're going to add to this. We're going to add some distortion. And if you've ever seen, once again, something broadcast over the air in like radio signals, or if you've seen a VHS tape or something like that, you'll notice that there's often distortion effects that happen where the image just goes nuts. It just gets all messed up, and it does not look very good. So we're going to add something like that. That happens occasionally, not all the time. So first we're going to get a time node, and we are going to get a sine off of that time node. So then we're going to put that into a panner, and the panner is just going to use the stock texture coordinates. We're not going to change anything about the texture coordinates, and we're going to pan 100 on the X. So this is going to pan very fast. And then we're going to need a texture for this. So the other texture that I had in my my Substance Designer project here is this anisotropic noise. And this thing works perfectly for what we want right out of the box. The only thing I've changed here is the Y amount to give it a lot more noise. And then I'm exporting that again as a 64 by 64 grayscale image. And then we are going to import that into our project here. We're going to save it. You can see it's grayscale, perfect. We'll go back to this. We're actually going to drag it in because that's easier. So we drag it in, we got our texture sample, and we're going to plug this into the UVs. And immediately you're going to notice this is just going really crazy, really fast, which is exactly what we want. However, this is going to be a little intense to start off with. We'll drag off one of the components here. We'll multiply by 0.5. And actually, once again, this is something that we can parameterize. Super easy. We're going to call that distortion intensity. We're going to give that 0.5 as a starting value. And so you'll see this makes it a little less intense. The movement will still be intense, but it won't be as contrasty, which is kind of what we want. And then we're going to just give this a shot and see what it looks like. So you kind of get an idea of what we're doing here, even though this is not ideal because we don't have it all set up just perfectly yet. But we're gonna add this to our textures, our texture coordinate. So you can see then it starts distorting where each bit of the texture is being displayed. If we apply that and take a look, you can see it does a pretty good job of getting that crazy, the entire image is being distorted effect where you can't really see what's going on, but you can kind of still see the image under there. You'll also notice that it offsets the image a little bit. If you don't want that, you can, after you add this distortion to the texture coordinate, you can then add to distort it or to move it back without distorting it. Just add a scalar to the whole thing. And you can do that in such a way where you scale the scalar that you're adding back by the amount of distortion intensity, such that if we go over here, let's see, I'll grab that, open this again. I did. What are you talking about? Okay, so you could do that in such a way, whereas you'll notice as you do this, it moves more and more. So you scale it by how much you're distorting it by. We're not going to do that here because I'm not going to distort it a crazy amount. I'm just going to do, like I had 0.5, and you can almost not even tell that it's like, once you get up to 0.5, you can't really even tell what it was, where it was supposed to be or anything like that. But you can, if you wanted to, make this distortion a little less intense, and that actually looks pretty cool because you can still see what the image is, but you're distorting it. But we're gonna stick with this. So now that we have this, one thing you'll notice is that it is constantly distorting, and we do not want to do that. We only want to distort at certain times. So you could do this via a parameter value through Blueprint, and you could set it up such that it goes off with the noise and all that kind of stuff. But we're not going to get that intense in here. We're just going to do this a simple way through the blueprint, or through the material graph, so that it only does it for a specific amount of time, and then it goes back to normal, and then it does it for a specific amount of time again. So the way that we're going to accomplish this is by taking the time and taking a sine of the time. And if we want to see what that would do, we can just take that right now. And well, actually, I should have done this a long time ago. Make this so we can see the monitor on here. So you can see with the sine, what it's doing is it's not distorting at 0, and then once it gets to 1 or -1, it's distorting it more and more. So we don't want to have it doing it this quickly. So first thing we're going to do is divide the time by 10 so that it's going much slower, and we'll see how that pans out in just a second. So you can see you can much easier see what's going on here. It distorts a whole bunch, and then when it gets closer to the center, it's not distorting that much. And then once it gets to the other side, it's distorting a whole bunch again. So we've got that now. What we want to do, though, is we don't want it to go into negatives, first of all, because you don't really want to plug negative values into a lerp. So we're going to do what's called constant bias scale. Plug that in. If you're unfamiliar with this node, what it does is it adds something. It adds a value to another value, and then it scales that value. So what we're doing here is we're adding 1 to sine, which means that instead of going -1 to 1, it goes 0 to 2, and then we're multiplying it by 0.5, so then it goes 0 to 1. So you can now see that it just kind of, it goes to the center, and then it goes to 1. So we've got that now. But we don't want it to just kind of gradually distort over time. We want it to be not distorted and then suddenly distort and then be not distorted again. So the way we're going to accomplish that is a floor. And what floor does is it rounds down to the nearest integer. So what we're doing right now, just plugging a sine in here, it's never getting to 1. It's going all the way up to almost 1, and then it's rounding it all the way back down to 0. So what we want to do is we want to bias this a little bit more so it gets just over 1. So we're going to do 1.1. And so for a very small portion of its life, it is going to be over 1. It's going to distort, and then it'll go back to being normal. So you can see that happening. Oh, I should not have moved that. So you can see that happening here. It distorts, and then it snaps back, and it's fine. And then it's fine for a long time because we set it up that way. And then it's going to distort again. There you go. So that's perfect. That's exactly what we wanted. We're going to call this distortion. We're going to save that. We're going to also save and close this. And now we'll take a look at this with the texture from the camera. So you can see now we've got a security camera that is feeding image into this monitor, and it's got a bunch of neat little effects that make it look a lot more like a CRT monitor and a bad closed circuit camera. So now we pretty much got everything we want. There's only one more thing I want to do here, and this will be super quick. If we go back into the security camera, we can set a frame rate such that this is not updating constantly. Because if you look, it's just updating. Essentially, it's drawing this every frame, and we don't necessarily want to do that. A, for performance reasons, and B, for aesthetic reasons, you might not want to do that. So first thing we have to do here is we're going to add has limited frame rate bool. And that's going to start off as no. But we're going to make that instance editable so that it can be changed for each camera. And then we're going to make a frame rate float. And we're also going to make that instance editable so it can be changed for each camera. And then I think after all this, but before it starts targeting, what we're going to do is we're going to add a call to we should make the function first. Custom event. We're going to call this set frame rate. And we're gonna call set frame rate. We're gonna plug this in here. So essentially what this is going to do, this is going to branch, and if this has a limited frame rate, it is going to set timer by event. And we're going to call this custom camera update, I guess. Work fine. And so this is going to then drag off of, where's that? The camera capture. And we're going to capture scene. So essentially what this is doing is when this fires, it's going to say to the camera, take a picture. So we need to give that a time. So what we're going to do is get our frame rate. And we're going to make sure this is looping. And we are going to divide, not divide, divide. And you want to divide 1 by the frame rate. So if it's 60 frames per second, it's going to refresh 60 times in a second. And then that's going to call that. So you would think this would work right off the bat, but it does not, because there are a couple things we need to change in the camera capture. So we're going to set these. We're going to set capture every frame, and we want to set that to no. So essentially what this setting is it's telling the scene target, or the scene capture, to capture every time a frame is rendered. We don't want to do that. It's a little expensive. We don't need to do that. I mean, it's not super expensive, but it gets more expensive the more complex your scene is. And then the other thing we want to do here is capture movement. So set capture on movement. Sorry, set capture movement. So essentially what this does, we don't want to check that. I wanted to check that. So essentially what this does is every time the scene capture component moves, it captures the scene. And we don't want that to do that because our camera is constantly moving the entire time. And so we don't want that to happen. We just want it to update when we tell it to update. So you want to set both of these things to false. And now, if all is well, we should be able to click on this and go over and set has limited frame rate. And we'll just do something that's very obvious, like 10 frames per second. So now you can see that as the camera moves, it is very jerky because it is only updating 10 times per second. And you can set what is appropriate for your game. Probably for this kind of thing, 30 frames per second would be good if you want something that looks kind of fluid but is not like taking up too much performance. If you're going for this closed circuit TV kind of look, the super low frame rate can actually be helpful, because if you've ever seen like footage of somebody like robbing a convenience store or something, it usually looks like this because they're constantly recording film over the course of days, so they need to keep all that on hand, so they're recording at a low frame rate. So if you wanted this to look like it was a thing that had been recorded in the past, this is the perfect kind of effect for that. However, if you want it to be a live kind of feed, then probably something like 30 would work just fine. Or you could go with 60 if you really don't care about the performance that much. But you see with 30, it actually looks pretty good. And something between 30 and 60 is pretty reasonable for a monitor. Most CRTs probably had a refresh rate of 60 hertz. So you would want something around 60 or less. You wouldn't want it to be super high because that just doesn't make sense. So that is it. We have a very neat looking material effect here on a camera that works, that traces the player and then loses the player. We could add more different things for it to track if we wanted to, but we've got this and it makes sense. We've got everything working as it should. And so that's basically all we wanted to do here. Whoa, that's cool. But that's basically all we wanted to do here. So we've got our camera working, we've got our material, and now you can make a security camera for your game that looks super cool. I hope you found this useful. If you have any questions about it, just put them down in the comments. Otherwise, enjoy it, and I hope you have a great day.